Welcome to the quadratic graph translations lesson. Okay, so we're going to learn about vertical and horizontal graphs today. So make sure that you have your note ready to fill in and have Google open to so we can find Desmos. So Desmos is a graphing program. So just type in DESMOS. And then when you get to here, the graphing calculator, go, and then you're ready to go. Okay, so we're going to be adding some equations and analyzing them with this investigation. Okay, so now I have both the note handout and the Desmos website open. So what you're going to do here is you're going to start by graphing y equals x squared. So with the Desmos program, you don't have to type in the y, but if you want to, you can. So there's a calculator keypad down here, which I have out of the screen right now, but you can click on it and it pulls up the different, I guess, hotkeys or just ways that you can enter the equations a little easier. So y equals x, and then this a squared puts the exponent 2 on there. Okay, so it quickly will graph y equals x squared. So over here on your note handout, I'm asking you, once you graph it with this program, because we're doing an investigation, what's the vertex, what's the axis of symmetry, and then it has this shaded in because you don't have to fill that in. Okay, so we're just going to fill in here. So the vertex, again, remember, is down here. And so we notice that it's at 0, 0. So we're going to put in the coordinates of the vertex. Okay, so always use brackets. Okay, and the axis of symmetry. So again, if you were to, where's my mouse here? Okay, so it would travel down here, right? So it cuts it right in half. So it would be here, so it hits at x equals 0, so the axis of symmetry, so whenever I ask for that, I want the equation, x is equal to 0. So we consider y equals x squared to be the original, I'll call it the parent graph a lot of times. So we're going to now analyze in the next one here, what if I change it to y equals x squared plus 3, what will happen to the graph? Okay, so we're going to go back to Desmos here. So we're going to click just right under where we had the parent equation. Click underneath here, and it allows for another equation to be entered. So again, you could just type this in with your phone or your computer. Y equals x squared, and then don't forget to write plus 3. Okay, so the nice thing is that the parent one was red, and now the next graph is blue. So again, we're just going through an investigation here, so we're just looking at properties, and then we're going to see if we could start to actually fill this table in without graphing the graphs. So, so this next one here, okay, so the next one here, which is blue, it has a vertex now of the x value first, 0, 3. Sorry, change the color so it'll match the graph. Okay, so 0, 3. And the axis of symmetry, well, still in the same spot. Okay, a new area of the table to add information to is now compared to the original y equals x squared, how has the graph y equals x squared plus 3 changed? Okay, changed, I guess, the position of the graph. So here we would say it shifted up 3. So if you look at all of the points, they actually moved up 3. Okay, so the vertex is the easiest one to see here. All right, so from here, maybe you can predict what will happen if it's minus 4. Okay, so we're going to go over here and add in y equals x squared minus 4. Okay, and it's green. I'm going to just switch the pen to green here. Okay, so we're going to analyze the vertex, and we're noticing that it's still at 0 for the x value, and then this time it's -4 for the y value of the vertex. The axis of symmetry still in the same spot, but we can describe this as, so up here we wrote shifted up, shifted 3 units up, so this one would be shifted 3 units down. I'm okay if you just write down, or it wasn't 3 units, 4 units down, okay, down 4. Okay, so from there, make a prediction with these next two, and then go ahead and graph them and see if you're correct. Okay, so for the last two here, hopefully you saw that, okay, if it was +3 in the equation here, oh, it went up 3. It was -4 in this equation here, so it went down 4. So hopefully you predicted that, oh, this +5 would have made it move up 5, and -6 would have made it move down 6. So from there, but the axis symmetry, it's still in the same spot. So this graph did not move left to right. It was just moving up and down. The vertex was changing, but we've noticed that the x value of the vertex was still 0. Okay, so kind of a pattern here. The vertex is all 0 for the x value. Oh, and the axis symmetry is x equals 0 as well. So let's make a concluding statement here. I'll use blue. Yeah. Okay, so for x squared plus k, so whenever something is added on, we notice that the graph moved k units up. Okay, and when it was y equals x squared minus k, the graph of y equals x squared. So if it was minus k, it went k units down. Okay, and the proper terminology here is that there was a vertical translation. So you would say there was a vertical translation for this last one here. Vertical translation down by 6. For the second to last one, the purple here, there was a vertical translation up by 5. Okay, but again, I'm okay if you just say up and down, just yeah, just describe it, that's fine. Now we're just going to graph a few graphs here, just kind of so that we can refer back to them later. So if you want to go to Desmos here, the nice thing about it is that, you know, it's all color coded, so you know which equation matches which graph, but you can also click on the colored circle and turn them off. They'll still be there, but you can turn them off. Okay, so we're back to our original parent graph here, y equals x squared. So I want you can even zoom in by, yeah, just swiping with your screen on your phone or with your mouse and stuff. So if you take a look at, there's some really good points where they go through some nice crosshairs, I guess you can think of them. So if you look at this one, 0, 0, there's 1, 1, then there's this 2, 4. So let's graph that on this graph here. Okay, so I'm going to use red again. Okay, so we have, or maybe I'll just use actually gray for the dots. Okay, so we have 0, 0, 1, 1, and then it was 2, 4. Really nice points. And if you go back to the Desmos graph on the other side, oh, -1, 1, -2, 4. Oops, sorry. Oops. Okay, so and then you want to draw a nice smooth curve. So a parabola, which is the name of this type of graph, or quadratic relation, you'll see that it has a nice smooth bottom here. So it's like a U, but then its arms keep going out like a V. Okay, so make sure that your parabolas always look like that. They shouldn't be pointy here at the bottom, because that is a different function that you're going to learn next year. So make sure, again, smooth curve, and then don't forget the arrowheads. Okay, so I usually draw the bottom here first. Okay, and then you want to extend. If it's a little bit wobbly, it's okay. Oh, okay, that's horrible. All right, and then here's the next. Okay, let's just try that again. Okay. Oh, goodness. Okay, so then extend out to there. Oh, do your best to hit the points. I missed that one slightly, but here we go. Y equals x squared. So the main thing is you'll see those points there, and then I want you to draw the next one, the say y equals x squared plus 3. So if we go back to Desmos here, we can unclick here. What are we noticing? Okay, it moved up 3. Okay, so what about this point here, 1, 1? Oh, it also moved up 3. Okay, this one here moved up 3. So we're gonna, I guess, use our, I don't know, we can use a different color this time, I guess. Make it light blue. Okay, so so this vertex here, 0, 0, became 1, 2, 3 up. There it is. This point here, 1, 2, 3 squares as well. This one, 1, 2, 3. So everything translated up by 3. Okay, the same as this side. Okay, and then we'll connect it with a nice smooth curve here. Try better than I did last time. There we go. And there you go. Okay, so y equals, and then yes, don't forget the arrowheads, don't forget a smooth curve, and don't forget to label. Okay, the graph with the equation. Okay. All right, and we'll do one more here. The green. Oops. I'll give it pink points, I guess. All right, so so if you look over here on Desmos, again, let's click this one on. So what, compared to the red here, so we can hide the blue, compared to the red here, we notice that the vertex 0, 0 dropped down 4. Looking at this point 1, 1, same thing, it dropped down 4, and so forth. If you analyze it, you'll notice that they all shifted by 4. Okay, so we'll draw that over here. So we went down 1, 2, 3, 4. Okay, this one dropped down 4. This one dropped down 4. Okay, this one went down by 4. And there. Okay, so now we'll use the green. Draw a nice smooth curve. Okay, so again, it's a bit wobbly, it's okay. Use the whole graph. Extend it all the way through the whole graph. Okay, arrowheads, and then label the graph. Okay, there you go. Okay, so we've noticed that the y equals x squared, the parent, if you add some values onto it, it will move up. If you add or subtract values, it will shift down. Okay, so here is a graph that you can refer to later. All right, so let's move on to the second part of our investigation. Okay, so now compared, like here it was plus k minus k. So what happens now if we modify the equation this way? So we have brackets x plus h squared or x minus h. So we're going to see how the graph changes with these ones. So we're just going to go back to Desmos here, and we're just going to hit the X here to just quickly get rid of the old or the other graphs. And again, we have y equals x squared. So go ahead and add that information to the table, and just feel free to continue ahead with this investigation. You don't have to wait for the video here. Just double check at the end. Okay, so I'm noticing here that the vertex is 0, 0. Axis symmetry is x equals 0. Okay, so y equals x squared, the vertex is 0, x's symmetry is x equals 0. Okay, we're not going to write about how it's changed compared to itself. Okay, still the same thing. All right, so we're going to now enter this value here, or this equation here. So we'll click on any equation here. Y equals x, or bracket x, minus 4, right? Minus 4, yeah. Minus 4 bracket squared. Oops, too many brackets. So what did we notice about the graph? Oh, it's red. Let's change it to blue. So just hold it down and then you can click it to a different color. Okay, so we noticed, let's see here. So the vertex is now at 4, 0, and the axis of symmetry is at x equals 4. Okay, so let's add those in. Okay, and what did we notice compared to the original graph? It moved 4 units to the right. Okay, so we could, and again, it's acceptable to just say right 4. Okay, so maybe you were trying to predict that, and it was a bit of a surprise that it was actually to the right. Okay, so maybe from here you can kind of take a guess which way do you think this will go then. All right, so let's graph it here. Okay, so let's change it to green. Hold it down, green, and out. Okay, so oops, turn it on. Okay, all right, so there it is. So it was plus 2, it went left 2. Okay, so the vertex is there now. Oh, you can, and the axis symmetry is there. So let's add those in. Okay. Oops. Should be green. Minus 2, negative 2, and 0, and that's where the axis symmetry is as well. Okay, so hopefully you're starting to see that wherever the x value of the vertex is, okay, that's what the axis symmetry is. Okay, so that makes sense. Okay, the axis symmetry always hits the vertex. Okay, so the x value of the vertex is always the axis symmetry. All right, so we are going to say here that it shifted left by 2. Okay, so we don't have to say negative 2 because we're already saying left. Okay. All right, so from here, can you guys predict what these will be? And go ahead and, yeah, so predict it and then go ahead and graph it and see if you're correct. Okay, so hopefully you predicted, okay, so if it was plus 5, it actually goes the other way. So minus 5 and x equals negative 5. So if we look at the orange now, this one here, yes, we are noticing, so we shift it over, it did move to negative 5, okay, and the axis symmetry is there, so it went left 5. So for the last one, x minus 3 in bracket squared, so there it is, the purple, it slid over 3 to the right. Okay, so we can make a conclusion here. So if the equation has this form where it's x minus h, you're going to move h units to the right. Okay, so just the opposite of what it looks like. And if it's x plus h, so again in brackets, then you're going to move to the left by that many units. Okay, and we call this a horizontal translation. All right, so next we're going to graph just about 3 of them again, and so that way we can use it as a reference later. Okay, so we'll start with the parent graph. So again, if you look over at Desmos here, we'll turn them all off. Oh no, I didn't mean to erase them. Oh, good, you can do Control Z. Okay, so we are just going to turn the colors off here. Okay, so yeah, so let's plot the vertex, 1, 1, 2, 4. Oh, I should use a different color. Oh well, it's fine. No, I should, okay, change it to black. Okay, so this way we can see the points really well. We look at the shifts. Okay, so now again, smooth curve, nice U shape down here, and then extend out. Oh, try to hit the dots though. There you go. Okay, oh, that's wobbly. Y equals x squared, there it is. And so then we'll graph the next one in brackets with x minus 4. I'll use light blue here. Oops. Okay, so it's minus 4, so it's the opposite of what you think. You're going to shift 4 to the right. Okay, and all the points will do that. 1, 2, 3, 4. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4, etc. And then this one, 1, 2, 3, 4. That's right back on top of this one. Okay, and smooth graph. Horrible. Okay. There you go. And then we're going to label that one. Hopefully this fits. No. Okay, so the red's the original. Okay, so this one moved 4 units to the right. Okay, so then we graph the next one, x plus 2 all squared. So you'll see that all the dots move 2 to the left. Okay, so they call this a horizontal translation, okay, because you're doing the left-right movement. And up here, this was the vertical translation because you're moving up and down. Okay, so from here, hopefully you saw the pattern. Yeah, you saw what it was doing when it came to finding the vertex, finding the axis symmetry, which way it moved. Now I'm hoping that you can finish these off here without using Desmos, and then go ahead and write pencil stuff in, and then I use Desmos to double check. But hopefully after a while you understand where the pattern is, and you can predict where the transformation, where the new graph will go. And then there's some here that it's a combination of both left, right, up, down movements. Okay, so vertical and horizontal translation. So be able to, again, add both of those in. I'll do maybe a couple with you. And then also graph these as well. Okay, so again, if it helps, draw the parent in first and then draw the new transformed graph. Okay, so we'll start with just doing maybe like a couple of these, and then we'll try somewhere there is a both transformations here. So the first one here, so again, like A and B are different. What's different is that there's this bracket here, right? So that's important. So when X was in a bracket with a number, this is the left-right movement. Okay, so then when it was minus, it was the opposite of what you thought. So, again, you can start here. It goes right 2. Okay, so it's going to go right 2. So again, if you can visualize that, what's the vertex going to do then? Well, it used to be at 0, 0. So now if it's just shifting right 2, the vertex will be at 2, 0. Okay. And then we found that anytime, whatever the x value is for the quadratic, that's what the axis of symmetry equation is. X equals 2. Okay, so we'll try the next one here. Use a different color. So this one here doesn't have a bracket, so it's not the left-right movement. This is the up-down. So whenever it was plus a value, you went up. If it was subtract a value, you went down. Okay, where the one in A, it was the opposite of what you saw. If it was minus 2, you go right 2. Okay, so this one here, you will go down 7. So again, it doesn't matter which order you fill this in. You're going to go down 7, and then, so if you were visualizing, it used to be at 0, 0, so it went down, it didn't move left or right, so you have a vertex at 0, -7, right? And then the axis of symmetry, where do you look? At the x value is equal to 0. All right, so hopefully the left, right, up, down, the horizontal and the vertical translations are good. Let's jump right to like E and F here where they have both. Okay, so if we take a look here, so when it's in a bracket, it's left-right movement. When it's not in a bracket, it's just out here, out without the brackets, it's an up-down movement. So we go to E and F now. We have a couple things happening here. So when it's in the bracket, that's what's determining what's happening to it in a horizontal translation. So again, if it was minus, you go right. If it's positive, you go left. And then this number out here is kind of like this -7 out here. It determines which way it's moving vertically. Okay, so let's add in this information here. So I'll start off with describing it first. So this, -1 is going to move it to the right by 1. And then this, the +3 tells you that it moved up by 3. Okay, so move to a different color here. So then let's try F. So F, again, we have a couple things happening here. So there's something within the bracket. So again, that's going to determine, so we're looking at F here, something in the bracket. So that's the part that determines left-right movement. And the number outside the bracket here is like the 7 here. It determines up or down. Okay, so again, if it's +4, it's the opposite. What do you see there? You're going to go left 4. Okay, again, don't put the signs in. And then we have the 5. So you're going down 5. Okay, and again, there's no sign in there. Don't put the negative in. Just you're saying down, so we know which way it's going. Left, which we know which way it's going. All right, let's fill in, the rest of it here. The axis, or the vertex. So we know that it went left 4, so that's -4. And it went down 5, so -5. So again, it used to be at 0, 0, and that's where it is now. And again, axis symmetry, look at the x value. Fill in the other one. Okay, so the vertex here, so it was -1, so you went right 1. The vertex from 0, 0 became 1, and then went +3, it went up 3. So it went right 1, up 3. And the vertex is 1. Okay, so I'm going to graph E here. So you can see what you're supposed to do with these ones down here. So you can always graph the parent to kind of figure out where to move the dots. Okay, so let's draw in the x and y axis here. Okay, so I'll draw in the parent, use red again. So what you found with the parent was always, it was 0, 0, 1, 1, 2, 4. Do your best to nice smooth graph, y equals x squared. Okay, so with E here, where all of the points are going to move to the right 1 and up 3. Okay, so I'll use blue, I guess, here. Okay, so we're going to graph E here. So all of the points are going to move right 1, up 3. So the vertex here, right 1, up 1, 2, 3. Okay, right 1, up 2, 3. Right 1, up 1, 2, 3. Right 1, up 1, 2, 3 there, and then right 1, up 1, 2, 3 there. Okay, and then making a smooth graph here. Lovely. Okay, so and then label it y equals x minus 1 squared plus 3. Okay, so the vertex is at 1, 3, axis symmetry is there, and again, if you want to just double check that you actually did that correctly, you can look here and type that in, y equals bracket plus 3. Okay, change it to hold it down, blue. Okay. All right, so if you take a look here, the vertex was at 0, 0, so now it's 1 over and up 3. This point here, that was 1, 1, 1 over, up 3, etc. You can analyze the other points and you can go from there. Okay, so hopefully now you have a good understanding of vertical and horizontal translations of quadratic graphs. So go and just finish these off and yeah, practice a few more graphs and try the checkpoint once you're ready. All right, good job.